All right, we go to the next speaker, who is David Kinsey. So David works already in the industry for a long time with a particular emphasis on network management. So currently he is co-chair of a working group in ORAN Alliance to define the operation and management architecture. And in particular, he's also co-chair of the ORAN source community. So this is the hat that he wears now for his next presentation. So in the ORAN source community, he demonstrates various aspects of the overall ORAN architecture, and now he will talk about the East Coast Bedminster Open Lab CI/CD.
Thank you. So as said, I'm wearing a hat. This is my favorite hat. This actually is my grandpa hat, so just in case people wonder what my favorite hat is. Yeah, so I'm going to talk a little bit about I think this works. No. Let's just do it this way. There we go. So, as it said, it's our Bedminster lab, and it jumps to. Nope. Okay. It's showing slide 3. On here, it's like what?
Can we? I think it left the presentation mode. Maybe. Let me just do a slideshow.
And if you go back a slide. There we go. That's right.
Just this one, please.
Yep.
Forward.
Just the forward. Okay. So, Mike. Let's see. Can you hear me now? Okay. Okay, so our Bedminster lab is in Bedminster, surprisingly. And the purpose of this particular lab is really has a focus on the SMO, but it's also for end-to-end. So the goal here is because the SMO manages everything, is that we have a little piece of everything there. So it really provides that end-to-end environment. And our Taiwan lab is replicating it to some extent. They, of course, are building it from scratch, so they're using newer hardware. We're scavenging what we can and building it, but it's still functionally the same thing. You see a lot of things on here on the future because we have a lot of aspirations for this lab. Primarily is that we continue to expand our OCloud architectures. We had intended to do the 3 cloud or the 3 server architecture, but we never got the servers allocated to us for that. We are hopeful now that we will get those. I've been assured we will get those, plus a few more, and I'll talk about why. We also have initiated ORAN has proffered up the money, so they're financing the money to get us some test tools. We've been relying on generously loans from Viavi for TM500s in both labs in Taiwan and in Bedminster. Those are loaners, and so when it leaves, it inhibits our ability to continue testing from that end-to-end perspective, or from the radio aspect of the interfaces between the DU and the ORU. And so we found that to be a limitation. And additionally, we identified a benefit for having a RIC tester, so that we have several implementations of RIC coming out in open source and elsewhere. We have a variety of different apps that are being developed. And this was the focus of our US West lab is to do that. But in order to drive those tests in a standardized manner, we opted to also get the RIC tester. So those are 3 tools that we're in the process of acquiring. It's been slow for a variety of reasons, but it finally looks like by the end of this year, we will have those 3 tools available to us. We also want to get it to where right now our SMO comes up, but we run our tests and then it gets torn down and it gets rebuilt in a different manner for the next scenario of testing. And we want to get to a point where we actually have a continuously running SMO that is always up. It's always running. And when we determine that there's an update of a new feature, we would continuously then integrate to it and deploy to it. And so that's something that we want to get up, but it requires some dedicated resources. And then the purpose of having that thing is because of these interconnects. We had hoped that our lab would be up and running and interconnect to Northeastern by the time of this workshop, but we've been plagued. The current status, we'll talk about that in a second, okay? But yeah, so we wanted to interconnect our 3 labs, Bedminster to San Jose, Bedminster in Taiwan, okay? Go to at least 1 university lab. We had picked Northeastern first to try and do it for this workshop. I'm not sure if that will remain the first, because now we've seen others that we want to do. That has to also do with the current status, okay? And then to do an interconnect with OAI labs as well, so we can deploy there. And I'll show you the vision of the architecture that we have, that it would allow this interconnect to work, and so that the SMO could virtually deploy into any lab that we're connected to. Problem is this current status. We're moving our lab from one Bedminster address to another Bedminster address. And we were assured, totally assured, that the impact would be very minimal, okay? And that when it came back up in just a few weeks after the move started, that we'd be exactly where we were when we left, okay? Well, they started the move in pretty a little bit delayed. So it was supposed to start in June, be done in July. They started in July. It's not done still. Our problem is supply chain. We've encountered a problem with a major segment of our power not having the breaker that is required to power that section of the lab. So part of the lab doesn't have power. So additionally, also our chillers are not fully installed. And so as a result, we've been operating on temporary ones, but those temporary ones are smaller, and we can't, even with the limited things turned on, we can't keep the place cool. So we're prioritizing what things get on, what things get off. And our OSC resources are like at the low end of that priority list within AT&T. So we're currently without the lab. So that's an issue. And we heard this yesterday in Ganesh's talk. We're down because the loaner in Taiwan had to be used for another demo. And so we're without an RU simulator in Taiwan. We expect to get that back hopefully in December, okay? And we're down in the Bedminster lab, and we still don't have our testers back. We had a TM500 in the Bedminster, but as we tore it down, we sent that back to Viavi because they had another demo that they needed to do. And moving the equipment is not always that simple because it's a crate. We have to pallet it up, put it on a crate, and ship it. It's physical. And then to get it back, we have to reverse that process. All the cabling and power and everything like that. In fact, in our Taiwan lab, we had a delay there originally because of the fact that they had been on a TM500 Lite, which is the one that we're buying. Okay, and now the new loaner is a TM500. Unfortunately, the circuit power demand of the TM500 is much higher than that of the TM500 Lite. And so they had to actually have a whole new outlet. Well, that's a facilities request for their lab. And so they were delayed in getting back up with even with that. So we've been challenged in our labs. So to get access to the labs, these are an open lab. Okay, all it really takes is coordination with a PTL, any of our projects. If you want to contribute to a project, you talk to a PTL, say, hey, I'd like to contribute to your project. Okay, and they will identify that the PTLs are allocated a piece of the lab, and that they can use, and so they might be able to use within that space that's already there, or they may need additional resources, and that's when they reach out and say, oh, we need this many resources to be added to the environment in order to do this additional work. The last request we came in was for Tacker development. They needed a few new servers capacities for 2 different streams of work, and so we had to up the allocation to the SMO project. And the way you do it, there's a web page here. Hopefully you'll get this with the things. The page on the right is what opens up. That was shown yesterday on James's thing. So you can get to this page on the your right, my left. And I don't think you have to supply the public key. I think you get that back. It's because that's what you see down here on what you're receiving, is the credential. But we ask for email affiliation. Now it's really hard on the affiliation. You keep your own. Okay. Okay. See, I learn something new every day. But this stuff comes in. It's sent to me. You can see my name's up there at the top. You send it to me. But all I'm doing is checking with the PTL that the PTL knows these people. They know what they're going to be doing. And then I forward it on to a lab tech guy. They actually do the work, and they're the ones that send out the email to the one that's registered saying, hey, here's your credentials. So I'm very much just a middleman here in terms of the gatekeeper. It's essentially all I do for the lab in that regards. So this is sort of our lab architecture before the move. Okay, and what we have is we have some physical boxes over on the right side here where we have our TM500, and it is connected through a front hall gateway that is connected to a Grandmaster clock. And we had experienced sync issues between the ODU. These are PNS, physical devices, physical platforms that came from Intel, and we had sync issues between it and the Viavi, and we couldn't maintain a session. And that's why we introduced the front hall gateway and the Grandmaster, is to make sure that they were all syncing off of the same consistent high resolution clock. Excuse me. We haven't really updated the OCU. We were running the VNF version in the new model now that we have O clouds in the lab, and this doesn't show the O clouds in the lab. It moves to a containerized version. We do have that containerized version up and running on an O cloud instance in Taiwan. So we just haven't updated the environment here to move to that. The core emulator, we're looking to replace that. That's one of the reasons we want to interconnect, is we want to go to like the OAI core instead of using an emulator, and actually then be able to be connected to essentially a real core and not just a simulator. We do distinguish out the three planes, the user plane, control plane, and the management plane. And we do that for consistency when we build the clouds. So the clouds all have that same level of interconnect, and that makes it easier when we start deploying, that they're already stitched together. And you'll see that on our futures. The left where the SMOs are, that's mostly on VMs today. We are not running our SMO on an O cloud. But and it doesn't show all our projects yet, because you see OAM, SMO, and non-RT-RIC. It doesn't show the AIML, but there is AIML resources that are allocated to them out of the VM space of the lab. So this is sort of where we want to go. Basically, a lab, Bedminster, looks like an O cloud. And within that O cloud, we actually have several different sites. Cloud sites is what the ORAN term form are. And within those, we build clusters. We are not doing any stretch clusters or multi-site clusters in the lab environment. They are pretty much dedicated to the cluster at the thing. But we have different configurations. You can see we have the AIOSX, which is a single server model. It has the control and the deployment plane all on one server. We have one that's the OAI DU, which is actually what they call a duplex, AIO duplex model. In the infrastructure project, it's a 2-server model, still split so that part of the workload and part of the control plane are on both nodes. And then once you get to these the plus models, that's when you're moving over to a 3-server or 3-server plus, and that's where you have dedicated control plane servers and then dedicated worker nodes. But this allows us, when they're registered with the SMO, you register the O cloud, and you see the IMS and there's a DMS too before deploying to that environment on its own in the very center here. And from the IMS, we learn about the DMSs of all the other clouds. And so really we can introduce any O cloud, regardless of where it is, and then the SMO will interrogate its IMS and find its other endpoints. And that way now we can deploy to basically any cluster in any O cloud that we're connected to. And so that's the thing. We use iDRAC in our lab. It doesn't have to be iDRAC. That's just because we're based off of some Dell hardware. It can be IPMI. It can be whatever your infrastructure is for bare metal controls. The cloud needs to have access for bare metal control. And for us, we also you can SSH to any of these servers that we create. Our goal is, if you see up on the upper left, is that the SMO it eventually does run on an O cloud. We want to be a little more dynamic, a little more ability to use some more cloud native instead of VM based. And this is also where ONAP is going and where other things are going. So we think that's the right way for us to move, is to be more cloud native in the approach of the SMO, and therefore also be able to be running on a cloud rather than in dedicated VM space. So that'll be a change when we get there. But it requires us to adopt a CI/CD process that is yet still being discussed on how do we get there. It'll probably be in our next J releases, the initial CI/CD process for the SMO, because it's composed of not just our 4 projects in OSC, but also parts of components that are in ONAP today. And if we start also then bringing in Kubernetes, Nefio components too, we would want to adopt a similar strategy for that so that we could bring those components in and start them up as well. So we're trying to get very modular in the approach. ONAP is actually sort of leading the way in some of that because they're very large. They were very not componentized, but they're moving to that with an architecture. And I have a colleague who works in that space, and he's a techie. He's blood and guts, about the stuff of how it actually works, deep down inside. And so he's in it, and he likes the heck out of it. He says it's really awesome. So this is a guy that I think walks a little bit above the floor. He's never really in the same place we are. But he's really impressed with what they're doing with ONAP for the CI/CD process. So we're exploring that and looking at it. And that's pretty much the Bedminster lab in a nutshell. Any questions?